Let's begin! Plate boundaries are the lines at the edges of the different pieces of the lithosphere. And lithospheric plates are moving due to the convection current in the Earth's interior. There are two types of crust. The continental crust, which is thicker but less dense, and the oceanic crust, which is thinner and denser. Remember, the Earth's lithosphere moves slowly and constantly over time. It rides on a warmer, softer layer of the mantle called the asthenosphere. This movement causes the formation of plate boundaries, namely divergent, convergent, and transform plate boundaries. To better understand these plate boundaries, let's have a short experiment. And for this experiment, all you need are Oreo cookies. In this experiment, the upper cookie will represent the lithosphere. The creamy filling is the asthenosphere, and the lower cookie is the lower mantle. As mentioned earlier, plates move in three basic ways. Let's look at them one by one. First, choose a cookie, and remember, don't eat it yet. Now, carefully remove the upper cookie. A twisting motion is required. Slide the upper cookie over the creamy filling. This motion simulates the movement of a rigid lithospheric plate over the softer asthenosphere. Then, break the upper cookie in half. Now, gently push down the two pieces and slide them apart. What happens to the creamy filling? The two pieces represent the lithospheric plates. When we push down the plates and slide them apart, the creamy filling between the two broken plates may tend to flow upward. This demonstrates a divergent boundary. It happens when two tectonic plates move away from each other. And when that occurs, magma or molten rock escapes or rises from the Earth's mantle to the surface or into the space between the spreading tectonic plates. Divergent boundaries can form within continents but will eventually open up and become ocean basins. On land, divergent boundaries within continents initially produce rifts, which produce rift valleys. The most well-known rift valley on Earth is probably the so-called Great Rift Valley System, which stretches from the Middle East in the north to Mozambique in the south. The area is geologically active and features volcanoes, hot springs, geysers, and frequent earthquakes. Under the sea, the most active divergent plate boundaries are between oceanic plates and are often called the mid-oceanic ridges. One example of a ridge is the Mid-Atlantic Ridge, an undersea chain of mountains that formed as two pairs of tectonic plates spread apart. Wonder Warriors, how are you so far? Don't forget to take note of the important details in a piece of paper. Remember, by taking notes, you can easily remember our discussion. Got it? Let us proceed to the next step. Using the same Oreo cookie, slowly push the two pieces toward each other. What happens to the creamy filling as the two pieces slide together? This demonstrates a convergent boundary, which happens when two plates are colliding. Collision can take place between two continental plates, two oceanic plates, or continental and oceanic plate. Typically, a convergent plate boundary, such as the one between the Indian plate and the Eurasian plate, forms towering mountain ranges like the Himalaya, as Earth's crust is crumpled and pushed upward. In some cases, a convergent plate boundary can result in one tectonic plate diving underneath another. This process is called subduction, which involves an older, denser tectonic plate being forced deep into the planet underneath a younger, less dense tectonic plate. When this process occurs in the ocean, a trench can form. Mariana Trench is the deepest part of the ocean and the deepest location on Earth, which is 11,034 meters deep. Did you know that if we placed Mount Everest at the bottom of the Mariana Trench, the peak would still be 2,133 meters below sea level? That would mean you need to stack about 13 Burj Khalifa buildings on top of each other in order to assume how deep the Mariana Trench is. Amazing, right? And now, let us proceed to the last step of the experiment. Try sliding the two pieces laterally past one another over the creamy filling. What do you notice about the cookie edges? You can see that the plates do not slide smoothly past one another. This demonstrates a transform plate boundary. It occurs when two plates slide past each other. The relative motion of the plates is horizontal. They can occur underwater or on land, and crust is neither destroyed nor created. Because of friction, the plates cannot simply glide past each other. Rather, stress builds up in both plates, and when it exceeds the threshold of the rocks, the energy is released, causing earthquakes. A well-known transform plate boundary is the San Andreas Fault, which is responsible for many of California's earthquakes. For you to remember the concept, let's replay the highlights of the experiment. First, when we push down the plates and slide them apart, the creamy filling between the two broken plates may tend to flow upward. This demonstrates a divergent boundary. It happens when two tectonic plates move away from each other. And when that occurs, the magma or molten rock escapes or rises from the Earth's mantle to the surface or into the space between the spreading tectonic plates. Second, when we slowly push down the two pieces toward each other, it demonstrates a convergent boundary, which happens when two plates are colliding. A convergent plate boundary can form towering mountain ranges or can result in one tectonic plate diving underneath another. And finally, when we tried sliding the two pieces laterally past one another over the creamy filling, we saw that the plates do not slide smoothly past one another. This demonstrates a transform plate boundary. It occurs when two plates slide past each other horizontally. So there, you have just learned about the different types of plate boundaries.